Hello, everyone. As Laura said, my name is MOSHE ZIONI. I'll be presenting DDoS mitigation epic fail collection. I have a bit echo. Okay. So DDoS, we all know. We all know the attack. We all know what's going on with that. We hear about it a lot. Everyone is attacked by DDoS. And because of that, us as a consultant, I should start over. The agenda today will start with the introduction about what we are doing here. Then we come along to the method that we are providing DDoS attacks. I am presenting DDoS attacks for 3 years now. And then some tactics from the internet, something that we all know. And then the actual stuff from the presentation is ready, set, facepalm. The whole meaning of this presentation is to present strategies that we see all over the place when we start and this kind of service to our customers. And the fail that we are talking about are fails that are originating just by implementing bad advice. So first of all, as I said, my name is MOSHE ZIONI. I'm head of research at ComSec. ComSec is a consultants firm originating from Israel but working mainly in Europe. That's about that. 3 years of experience in DDoS attacks. We are providing simulations, but you can call it attacks also. It's a real-world situation with a large botnet. So that's for 3 years. And before that, I'm doing mainly penetration testing and ethical hacking to customers. That's my second time in Hack in Paris. It's the first time as a speaker, and thank you very much. Thank you, Systream, and thank you all for being here today. And for this opportunity. That's it. That's the end of the self-promotion slides that you ever see. I will never mention it again. Now, our method is pretty unique in terms of how do we manage to do such a thing, and how do we manage to get some insight into those kind of DDoS attacks. Well, the problem is with DDoS attacks is that you are either the defender. You see the DDoS attack happens all the time. You see it impacting your systems. Or, on the other hand, you are the bad guy. You are the attacker. I'm not relating just about you all in this audience, but I'm talking about whoever attacks or defends from this kind of DDoS attack. Now, we took the hat of the evil spoke and the good spoke. And then in combination of that, meaning that we are all together, the attackers and the defenders. We are sitting as a red team and blue team coordination, and the blue team is on the premise of the client, and we are coordinating the attack on our offices and from our botnet from some evil den somewhere, like think of a bat cave. So from there, when we see the attack happening, we know exactly what we are doing. We know exactly what happens when. And the blue team is providing insight, it's providing analysis on the impact that the system suffers at the time of the attack. Together with those insights, we bring it together to the table with the red team and blue team, what exactly happened, when and why, and then we can say why and what went on the system and what deserves the much impact. The one thing that we didn't expect from this experience 3 years ago is to become something like no others in terms of how do we do it. Now, when we get to DDoS, the problem is that the information about how to do DDoS is something that is pretty not out there. There are many groups, but not so many groups that are providing DDoS, that are defending against DDoS. There are vendors with appliances, but no one really knows what DDoS is. Now, when you know what DDoS is, you eventually do not discover to everyone, to the world, to the community, what is a DDoS attack and why to do so and how to do so. And we're here to provide you with that also. So when we talk about fails, we'll talk about what kind of strategy was they're thinking of, mainly common strategies, but not always. The second part is what kind of a vulnerability that they provided by implementing this kind of strategy, and eventually how we exploited this kind of vulnerability. All the stories are true stories, nothing made up. All the things are from our experience from the last 3 years. So as I said, DDoS for everyone. You get DDoS, everyone will get DDoSed. And I'm not talking about the attacks itself, or I'm talking about the knowledge of how DDoS is working and how you can be better at DDoS. And we'll talk about that later. So run-of-the-mill DDoS attacks nowadays are relying much on network traffic. We are all figuring out, yes, now we have a DDoS attack with 3,100 billion gigabits per second, but it's not the term. We figured that from figures alone, we see that 53% of the attacks are less than 2 gigabits per second, which is not something that is pretty far-fetched for a bank. And our customers are mainly financial customers, like bank, insurance, and other financial concepts, and governmental, you have financial, you have institutional sets, and all other sectors, but mainly financial. So 53% of the attacks are less than 2 gigabits. That says a lot. That says that you don't need to have such a big gun in order to bring down a site. And that kind of insights for us put pressure on us to do something smart and not just bombarding something with this amount of gigabits. So when a customer asks if we can provide them with gigabits and over gigabits, we say, yeah, of course we can, but it's not the point. You will see that you will not need it. And I'll get to the method in a second. Most attacks out there does not require brains. So no brains attached, no one needs to control anything. You just need to have a large botnet, or maybe pay for someone that have a large botnet, and then to just bring out your guns out and you can attack some kind of a site. Many attacks are just UDP floods, meaning that no brain required. You just point out an IP, you just point out where to attack, and then it hits the soft spot of the network. But again, heavily relied on network bandwidth. We see a transition in network bandwidth in the last couple of years, which means that attackers find out ways and intelligent ways to find how can they amplify their own attack. When do they need to amplify an attack? Is that because when you have a botnet, let's say you can provide someone with 2 or 3 gigabits per second, let's say for a small figure. But then it costs you money to operate the botnet, no matter why. Maybe you pay someone, maybe you have a botnet that you need to pay for traffic, maybe you name it. You have many options to pay for someone in order to execute a DDoS attack. Now, when you amplify the network, means that you need to send just one packet, or maybe 2 or 3 packets, and then receive much more on the other hand. How does it happen? For example, a DNS amplification attack, something that is very, very popular nowadays for attackers, is to find a vulnerable DNS. This DNS server can provide you with information. That's what DNS does, right? Now, when an attacker spoofs his IP and then sends to DNS a query, which he knows that the answer for this query is 100 times more or longer than the query itself, now they have an amplified attack, because if the spoofed IP is the IP that he wants to attack, the DNS receives a query for one IP, he replies to the other IP that he thinks that queried him, and then eventually you have 100 times more effective or more heavy attack on the network side. Now, all of those are attacks that we see in the wild, but we didn't want to do that exactly, and we have some legal constraints for some of that, because we are legit, I can assure you. Now, when we have those legal attempts, we need to be creative in the way that we strike, and so we strike harder, and we try to say to attackers, be smarter, not because we want you to win, just because it's something that is not efficient. And if you want to test out a site, let's say, you will need to be stronger, harder, but not bigger. You don't need to have eventually a bigger gun. You just need to have something very small which can impact the site. So there is more to a website than a front end. That's the most massive thing. Most of the DDoS attacks, and we're talking more than 99% of the attacks, just doing virtual damage to a site, meaning that is providing with a temporary DDoS to a site. A site is non-responsive for a temporal time from the beginning of the attack to the end of the attack, or maybe a bit after the beginning, because it takes time to accumulate. And then when the attack stops for any reason, the site is back online. Now, we want to provide an attack to the site which will harm the site, not because we are evil, but just because we want to test its defenses and to prove a point. The point is that it's not just a front end, and you all know that, but the question is, how do you differ from backend and front end, and how do you attack a backend? We'll get it in a second. So overload the backend in making the system work for you. Remember that. As I said, we'll back to it. Now, the third thing is stealthy. Stealthiness is something that we call stealthiness just for, let's say, no signature-based attacks. Most of the tools online have signatures. Those signatures are sometimes by accident. Someone that didn't think of randomness, and the other vendors that are anti-DDoS appliances provide signatures for those kind of attacks. Let's say anybody knows Loic? Just before show of hands? Yeah? Great. Loic is a very popular tool by Anonymous. It was popularized by Anonymous as an attack tool, and it have pretty much for any kind of attack there, you have a signature. Now, if you're using off-the-shelf or off-the-internet tools, you will get signatures because everyone knows about it. The vendors know about it, and probably they will deflect your attack. We didn't want to be there for two reasons. One, we need to understand what we are doing, and we are not going to attack someone with a tool that we downloaded online. Second, we need to be stealthier than the tools that are online for that reason. And then when we have to do ourselves, all the tools that we are using are payloads that we wrote ourselves. We know for the bits, and we can change it and customize it in any given moment, whatever we want. So stealthiness is very important to impact the site, because you always have, let's call it noise to data ratio. So we try to make the noise as little as possible and not to be deflected for the most of the attack. The fourth thing is generalized term for amplification. Whatever we try to provide amplification with clients, just a second. Whenever we try to amplify an attack, we have a legal problem with that, because we need to implement those kind of attacks with a third-party DNS or a third-party NTP or third-party anything. So in order to amplify things, we thought over and over it, and actually we've got to understand some of the attacks that THC provided about SSL renegotiation, and when we saw that, it really proved our point, because SSL renegotiation and regular full session negotiation provides CPU amplification, because one side is just sending keys, the other side is working very hard in order to calculate and crunch numbers. So CPU is one kind of generalized term for amplification that we are talking about, but it's not the only one. When we talk generalized amplification, we talk about one, network amplification, which is pretty straightforward, as we said. The other one is CPU, and I just described one kind of CPU attack, but anything that is being crunched is CPU attack. Maybe you are familiar with another attack that was, I think in CCC 30 or 28, there was a POC for hash algorithm in all over the IIS, PHP, and other web servers. So check that out. That's a very CPU-intensive attack. Now, we have memory, which is another pillar. Memory is something that every process is using, of course, and mainly does not think of a DDoS. Just think of a mundane work on a system, whatever a system does. It does with memory. And memory is something that is very hard to really know what we are doing. Memory leaks are pretty common if you know how to find them. And I'm not talking about how to find them. I'm just stating a point that memory is many times the core trip in strategies. And the fourth one, you can guess it, is storage. Storage is something that is pretty much everywhere, and every kind of, even appliances along the way have storage. Now, the appliances themselves, if we are talking about switches, firewall, IPS, IDS, anti-DDoS, anything, have a very limited amount of storage in contrast to other storages like room servers, or maybe even if, of course, databases that provide much more storage than just an appliance. So storage can be harmed in two ways. One is just to clog the storage. You can provide the storage with more and more data, and we will see for at least one example of that. You can provide the system with much more data that it should, and then it can clog the system. The other one is the I/O buffer between the actual system and the hard disk, which will provide you with an effective DDoS, not an actual DDoS, because when you stop to overload the buffer, it should be okay, unless the MTBF of the drive was exhausted. Okay, so just before we start the fun, just some rules. One rule is no shaming policy. No customers or clients' identity will be harmed and will remain anonymous, no pun intended. Now, the second thing is meet Superbank. From now on, I will refer to any kind of client as Superbank, and let's say it's the same bank all over again, but mainly we're talking about the examples here are talking about banks and insurance companies whenever you think, but banks are mainly most of the stories are from banks, and pretty large ones in Europe. And the last thing is we will see 10. Remember, it's common practices. It doesn't say anything about best practices. We are talking common practices here. So if we see common practices, it doesn't mean that it's good. So never take an advice before you know that the advice is good. And that proved the point again. And the appropriate bypass and attack that we actually implemented on them. So ready, set, facepalm. 10, limit the rate of incoming packets. That's a really good advice, good in parentheses, that we have on many of our customers. The thing is with this kind of thinking and strategy is that you have a bandwidth and you want to save it for actual bandwidth, the bandwidth that you need. But actual bandwidth is something that is pretty, nowadays it's cheap, but it depends on whatever you are doing with your site and how intensive it is. And the Superbank has been attacked by a DDoS attack, and then they said to themselves, okay, what can we do? And asked the ISP that was offering an anti-DDoS ISP level defense. And then the ISP said, limit the rate of incoming packets. That way, you will control the incoming packets, whatever attackers will do, and then you can always be online because someone will know that the incoming rate is something that is under control. So first of all, the strategy itself is not solid as a whole. You can't really refer to incoming packet rate unless you know what is the correct rate. But let's leave it there for a second. The other thing is that it's really, really easy to bypass this kind of restriction. Why it's easy? Because we have reflection. Reflection is something similar to amplification, but the meaning is that whatever reflects from the server to you is something that is helping you to attack the server and maybe clog the bandwidth again, to choke it. So reflection to the rescue. We have a botnet and we have a server. We want to attack the server, but let's say we have a cap on our incoming packet rate for us. So we know the packet rate, or we need to guess the packet rate that is most probable to be, and we can go very, very low. Why we can go very, very low? Because the thing is that you have a simple attack for this. If you are just downloading from the site, you are implementing a reflection attack. Why is that? Because asking the server for a file is something like 1 kilobyte. 1 kilobyte alone, because you don't have much to do. Well, let's say 2 kilobytes. In worst case, let's say you have other session IDs, maybe you have anything that you need. You will not get anything more than 2 kilobytes unless it's not a file. So when you get a GET request into the system, let's say it's 1 to 2 kilobytes. So that's cannot be a limit for the rate that you are asking the site. But the site will come back to you with a file that with consuming the bandwidth that you find the file. As it will be better if the file is very big. Let's say 2 megabytes is pretty big. Gigabytes is pretty awesome. But if you find megabytes on the web server, that should do the trick. So if you send a 1 kilobyte request for a packet, GET request for a single URL, or let's randomize it a bit, so you have a list of files, and then sending a request for the file, it will never hit the limit. But then again, when the file will come back to you, it will clog the bandwidth. So eventually you will get the same attack, but now you are making the server sweat, and then the server is CPU intensive, maybe it's memory intensive, but most importantly, it will choke its own bandwidth. So that's a very, very easy exploit to do. So we are consuming the file length and consuming by reflection. Number 9. Number 9 is something that we approached early in the beginning of the service, and again, Superbank was attacked, and then they said to themselves, let's implement another thing. Now, very, very trendy nowadays is scrubbing services and other services that are online. They are providing you with redirection of traffic through them, and then they can maybe monitor your site and monitor the traffic, and then by brainstorming with all their clients, they can say, here is a good attack, and here is a good bandwidth, and here is a bad bandwidth, and let's detect this and strike it out. So when this kind of when Superbank approached this service provider, they actually had a monitoring system on their system. So we attacked the bank to see that the monitoring works, and the monitoring worked. It was great. But then again, when we say to them that the site is still off, they said it's okay. The monitoring shows that everything is okay. Why you are bothering with bothering us? We want to sleep or anything like that. So it's okay now. The monitoring shows that everything is okay, back to normal, and the monitor is being okay. We got the screenshot from the provider saying that the site is okay, and they were high-fiving each other in the room. We said we heard from the customer that there was much rejoicing, and then they sent us this image which shows clearly, I don't know how clearly, but it shows clearly that the peak time was off, and then by a couple of minutes or so, the attack was off. And then there was a relaxation. And when there is a relaxation, everyone are happy because the work has been done and everything looks okay. There is no way that the site is under attack because you can see it in the graph. The thing is that they didn't know is that the redirection of the DNS was not correct. The customer provided the service provider with one of its IPs that he needs to be redirected, and for other reasons, exceptionally for management of the site, he had its own IP, which the IP can be traversed by DNS querying. Whenever we asked different DNSs in different times, we got another IP. So we figured there is another IP in place, and we need to strike it down. So we struck it down. It was pretty easy because it's the same attack all over again. But now they can't detect us. So they were very assured that the site is not down. But whatever, you can actually check the site. It's something phenomenal. You can open up a browser and try to surf to the site, and you will see that the site is off. And that's exactly what wasn't done in this. So the strategy of monitoring is okay, and we all know it from other security operations center, but in this case, when you talk DDoS, it's very easy to comply to see if the site is up and down. And that's something that none of them, not IT and not the service provider itself, have been doing through the attack. Okay. Number 8, backend servers are not important to protect against DDoS. That's something that we hear a lot, and I talked about it earlier a bit, and I will provide some more information. We had a client that, this Superbank, of course, was under the assumption that the front end is very important, and the backend service was pretty lame in data, nothing crucial. So he put all his defenses on front end. He put monitoring, heavy monitoring on the front end. He put some ISPs. He put some anti-DDoS mechanisms. He bought some marvelous bandwidth to his system. And now he said, okay, let's do the attack. And you have to keep it small because I will detect you. I have the most efficient monitoring system in the world or something. So we said, okay, we surfed to the site. I haven't mentioned that research is done a week before the attack itself. We need to know what we are talking about. We need to know what kind of technologies are there. And we need to test some thresholds without harming the site in order to provide a customer's operation and something that will be precise as we can. So during research, we found that he had a simple query in a site. The query was referring to searching for branches and agents in those branches. And we used that. We said that if every pen tester is doing that, by the way, you should know that when you see a site and you see a query, you eventually will get, okay, maybe it's traversing a file, but if it's data that needs to be dynamic, it's most probably a database, right? So we found this query, and by measuring time by measuring the response from the server, we actually got the idea that it should be a database down there somewhere. So we queried the database all over again. We queried and queried and queried. So the traffic was, we kept it very, very low. But the traffic on the inside was insane because we didn't know, but could guess from time delay, that the backend is going crazy. Like every time that we queried the site, it took about 15 seconds to respond. That's something that shouldn't be done in any case. So when we time measured it and we figured that that's a database, we didn't need such a big bandwidth, and then we eventually attacked the backend through the front end. And if you manage to see, the amplification itself was self-inflicted. So eventually we have an amplification inside the network, and that's what brought the backend down. By the way, another fail in this, and that's because that's another reason it's here, is that this database in the backend that was referring as a lame database that just controls the branches and agents was much more than that, because when the database fell, some angry calls received at the SOC and for the security officer that said to them, "Are you crazy? You just dropped like 50 databases of the bank." And then they realized that the database is shared, and the shared database has been fallen by this kind of attack. And again, the attack is from the outside. So we have a chain of events that was pretty funny for us, but not funny for the customer. Okay, so now we have, again, something that very, very probable to do. When you have a big appliance, you pay it's very expensive, and you pay hefty money for that. You have an appliance for anti-DDoS, you put it in the on-premise, and you want to connect your domain to it. So you have a domain connected to it, and then you maybe think to yourself, maybe I have another domains to control, and then maybe I can deliver those kind of traffic through the anti-DDoS mechanisms. That's a great idea. Be effective, be efficient in your work. Does not just spend money on something that you won't use, right? Right. But then again, if you are not familiar what exactly will happen when you connect those, and if you didn't figure what will be the architecture right now and what will be the mitigation process, you are doomed to fail. And what exactly happened in this case, it was over the pond, some British customer, that a financial customer that bought a new and shiny appliance, just connected it to the network and connected all the things to it. And then the mitigation was, the strategy of the mitigation, and that's something that was written in the documentation for the appliance, is he is learning the traffic, and after 20 seconds, it gets into mitigation mode. It drops the lines and tries to dry them out and then to bring it all together. So when that happened, we just waited. We are doing a ramp up. So we are starting small and then eventually getting bigger and bigger. So we started small and nothing happened, which was pretty obvious that nothing will happen. But after 20 seconds exactly, the site was down without any given reason. The site was down, and not only the site, the monitoring systems, the management systems, the ISP, the VPN, anything that you can think of was down. All the financial organization, it was production system, it was on Monday, the start of the day, it was until 7 hours from then that the site or anything else on the premise was bring up to life, and during this, they learned a lot about something that was inside the system that eventually affected this weird behavior. What actually happened that the appliance thought of the lines as malicious and then dropped all the lines and then didn't give access to management. That's something pretty crazy, but that was a strategy of them. Number 6, we don't trust the vendor. That's something that is pretty hard to say, but that's something that we are encountering all over again when we approach startups, and they have anti-DDoS machines and anti-DDoS clouds that you can use. And most of them are even free. That's crazy, right? Why not use it? So you put on your credentials, you put on your reverse DNS, reverse proxy, and you have your DNS credentials, etc., etc. And then you have a redirection through the cloud with no money involved. That's something that is very, very important to most of the customers. Now, that's great. The only thing is that if we are talking layer 7 attacks, and if you don't trust the vendor and you don't give them the certificate, we're talking about SSL certificates, of course, so the traffic will not be shown on the servers, right? So if the traffic will not be shown and we still getting to DDoS you through SSL, you won't see the attack, and so you won't be able to control it. You won't be able to smartly mitigate it. And that's exactly what was done. We just flooded the website with HTTPS. And eventually we figured that maybe HTTPS was not required for the customer, but it doesn't matter. The HTTPS was the vector of attack. You just enumerate the surface and then you find out HTTPS. So HTTPS was pretty much it when we figured it out. And when we figured out that we have something inline that is providing us with some difficulties, but then again, when you don't have the certificates, you can't correctly terminate the session, the SSL session. Number 5, we need big data. Collect all the logs. That's something that we hear all the time, and mainly in the last couple of years or so, we have even a preference requirement under several regulations like PCI. It actually requires you to collect all the logs. It's something that is very crucial to someone. But it's not crucial when we're talking about DDoS because, as we said, storage is something very troubling. You can be clogged by storage, and then you have silo needed. You can't just expense storage unless you know how to control every kind of appliance. But then again, if you have this kind of appliance in place and you don't know it, the appliance will clog up the system. What happened is that we attacked this super bank, and then during the night when we attacked it, we figured out that there is no access to the site all of a sudden. And we haven't done something very massive. We're talking about maybe several millions of requests, which is nothing like a real attack yet. So we just started, and we saw that the IPS was not responding. It took some time to the bank to realize that the IPS was the problem, but the IPS was not responding. Not to management, nothing like logs, nothing that can be managed, nothing that can be accessed, and the IPS was inline. So every kind of traffic could not get into the site. The site looks phenomenal clean. Nothing on the site, no client. The holy grail for many of our customers is no clients on the website, web server. No client and no traffic on the web server. Now, when they figured that that's the IPS, they need to control it, and they needed to go to the IPS and reset button on it. So that's a pretty damaging attack. Okay, that's another thing that we've mentioned, that we are under attack. Let's use the scrubbing service. Scrubbing service, again, is something on the cloud that we can switch. We can flick a switch, and then it can redirect our data through them. Now, this scrubbing service, based on Australia, the same place of this customer, this scrubbing service said to the customer, you can flick a switch as easy as this. If you are under attack, just flick a switch and we will provide you with the extra mile. That's terrific, but not possible. Because if you have a learning mode, if you need to learn the system, that's what scrubbing service do. It differentiates between good and bad bandwidth traffic. And if normal traffic, it needs to learn the normal traffic and then to differentiate between black and white, it can't be done during an attack, because during an attack, nothing is normal. So all is learned during the attack. So eventually, all of the traffic was dry, because everything was under attack, and the scrubbing service does not help at all. Eventually, he needed to call the support guy, which was in his pajamas or something, because he wasn't so sober. And then he said to him, "Listen, we have a scrubbing service. We just flick the switch that you provide us, and nothing is working." And he said, "Okay, that's great." No, nothing is working. The website is off. So they tried to mitigate it, and during the night, and after like 3 or 4 hours, they controlled the situation somehow, and then returned it up to life. But the scrubbing service provider said to the customer, maybe next time you can buy from us the configuration and implementation service that we provide you. That's not a good advice over another not so good advice that this service provider provided us. Okay, number 3, and we are approaching the end. The CDN is something that is very trendy nowadays, very popular. CDN is like, the cloud service, the reverse proxy from anywhere in the world. If we try to get to CNN.com, and CNN.com is located geographically in Washington, we'll have from here to there several, maybe tens of hops. But we don't need that. We want to be usable. So we have a CDN that provide all the caches to all over the world, like thousands of computers. And CDNs is not dynamic, meaning that the CDN need to be on static information. Why? Because not static information, what is doing with the CDN is when you ask a server close to you about a site, let's say CNN.com, he will ask himself, have ever someone approached CNN.com? Does it reside in the cache? If it is, you will be provided with a cache. If it isn't, it will ask CNN.com, the origin of CNN.com, and then provide you with the answer from there. So if it's dynamic, meaning that if you have parameters on site, you won't be able to cache all the parameters because it's not possible. And if the CDN does not know the limited set of solutions or set of answers for those kind of parameters, it will never can be done. So when the customers buy out the CDN, he's very happy. By the way, it's a very good advice. Go and put a CDN on static stuff on your site. That's great. But on dynamic stuff, it's not so great, because dynamic stuff, again, it will require you to go over the cache. The cache is not there. A new parameter is in place, and it will ask the origin all over again. If we are doing methodically, so the site will be down because the origin cannot control all of this traffic, whatever what. And another thing, Akamai in this case, which was the origin, and no shaming involved, just that's the way it works. And Akamai said to the customer, do not use not static information. So in this case, when the monitoring was working on the origin, you couldn't say who is attacking you, just from where it's attacking you, because the IP is related to the cache server, to the CDN itself, and not the origin of the attack, the attacker. So again, not in cache. Ask the origin is falling down. Another thing about CDN, that you have many advices that are pretty bad out there. One advice that we approached, it's if you search Google, is for CDN origin protection. Origin is the single point of contact when the CDN needs new information and needs to be updated. When you search for CDN protection, CDN origin protection, you will get this site in one of the first queries. And it simply states, this is a simple trick, and it is also the best solution. Create some random, long set of alphanumeric characters and use that as a subdomain. Here is an example, just an hexadecimal value .domain.com, or Superbank in our example. And I should refer to the last sentence, can it be guessed? Yes, but highly unlikely. Can it be leaked? Yes, but highly unlikely. Is it true? So we thought over it, and we found a couple of ways to overcome this obstacle, because that's what we figured that most of our clients are doing. And I don't know about most, but every time we approach a CDN and we try to find the origin, one of those two worked. The first thing is to find another known subdomain of this domain and then enumerate its IIP and enumerate all the /24, 16, class B and class C to see for another IPs, and then maybe one of them is a domain. Now, that's pretty massive. You have to work hard in order to find out which domain is the origin. But we have another trick on our sleeve. Another trick is that who is service never forgets. You have who is history in the internet, and the internet never forgets. That's the whole thing. And if we try and figure out what the customer did, the customer bought out a CDN and then provided the CDN with the origin. Chances are that he didn't change the origin of the IP in the first place. He just changed position from one state to another, from single state to CDN state. And that provided him, if we are looking at the history of the DNS records, we will find out the last IP used. And maybe, just maybe, that's the IP. For example, we find out that there is one site that's doing it for free, but there are many sites that are doing it with a little small amount. So you have udns.info, and that you get, in this case, I just search for some kind of a malware-infested site named bing.com. And through that, we figured just the list of the history of bing.com. We never attacked it, of course, just for the example. Number one. That's a very common mistake. Block them, block them, and block them, and block them. What the customer did, and we know it as a strategy of this customer, is to block every IP that you see as alert. Many customers do that because when they see as something that is alerting them, they are afraid of something that will happen and just blocking them, whatever will do. But blocking each IP in a DDoS is something that is not probable because each IP can be considered one of 1 million bots. So maybe, let's say, just 100,000 bots. So block them in an IP level, it's not so smart. But what you can do, and again, it's not smart, but you can do, is blocking maybe on class B or C. So that's exactly what the customer did. In this case, the customer was in Israel, so we are talking about less numbers than that. But in France, you have 82 million IPs, individual IPs provided in ranges. And that sums up to about 1,200 Class B ranges. And this customer was providing the exact strategy that I just described. He contacted each Class B range that he saw as an alert and then put a code on that. In Israel, we have much less much less in ranges. We have like 4 million, and then like maybe a tenth of this kind of Class B. So in this case, we operated in Israel, and it was a very easy task. It took 2 minutes, not 10 minutes as it wrote right on the board. That's just a projection for France. But 2 minutes to block all IP ranges in Israel. So when customers from Israel, which is most of the customers in this case wasn't able to access the site. And just to put a cherry on top, the actual team that was monitoring the site could not access the site because of this restriction, like halfway along the way. Okay, so we are near the end. Collection, misconceptions. There is no magic pill, no best cocktail, forget about it. You need to practice. You need to practice your people. How to do it is up to you. Maybe on dry runs, maybe on wet ones like this one, maybe other kind of awareness program, anything, but just practice. Jason said it out loud. I'm saying it again. DDoS is a subset of DOS. Do not be confused. You can be DOSed. If you have a vulnerability in the system and it's vulnerable to denial of service, you will be DOSed without the whole hula and things like DDoS. Now, you can have all the toys and money in the world. It will not be sufficient in practice. I will repeat that once again. And last, for this presentation, last advice, if you won't do that, it's a threat. You can be evaluated for this presentation in the future. Okay, thank you. Questions? Questions? Thank you.